Today we are going to talk about inequalities in two triangles. So yesterday we looked at in one triangle, if we knew the order of the sides, then we could order the angles. Or if we knew the order of the angles, then we could order the sides. Today we're going to talk about how to compare two triangles against each other. We have two theorems that will help us do this. The first theorem is the side angle side inequality theorem. Back when we studied triangles in Chapter 4, we talked about side angle side congruences. This is a little twist on that. So for the side angle side inequality theorem, we are going to take two triangles and say that in those two triangles, we know that two sides match up. But instead of the angle between them matching as it did before, we're going to say one of those angles is bigger than the other one. So before, when we studied side angle side congruence, the two sides matched and that included angle matched. This time we're going to say the sides match, but the included angle doesn't. So if we think of this like a hinge, one of them is open up further than the other one. What should that mean? So if I've got two sides that match, but one of them is hinged open further than the other one, what would we be able to conclude in there? That the other side would have to be bigger, right? Because it's hinged open further, so it would take a further distance to connect those together. So we could say then that those two opposite sides, instead of being congruent to each other, one of them is bigger than the other one. So I'll mark with 4 and with 3. Okay. So a bigger angle will make a bigger side. Our second theorem is the side inequality theorem. Again, we had side congruence before. But this time, instead of all three sides being the same, we're going to have two sides be the same, but the third side not be the same. So what could we conclude there? That the angles aren't the same, and furthermore, the bigger side makes a bigger angle. So this is kind of the backwards information of the other one. So it's important that when we name which theorem we're using, which in the homework sometimes you will have to. You won't have to in every question, but sometimes it will ask you which theorem you're using. And on the test, sometimes I will ask you which theorem you're using. We choose our theorem based on the information we are given. So if we are given information about all three sides, that's side. If we are given information based on two sides and one angle, then that's our side angle side. So for some examples about this stuff, each color is a new problem. So those first two that are blue, that's one problem together. We're comparing those two triangles, and we want to say, what can we conclude in those triangles? We need to give our reasons for all of these examples. I suggest that you choose which theorem you do before you start marking anything extra in the picture about trying to make your conclusion. Because, as you noticed, if we just look at those two final pictures that we drew for the two theorems, they ended up being exactly the same picture. So it's easier to choose your theorem before you start marking extra stuff. So in those first two blue ones, what information are we given?
That there are two sides that are congruent to the other two sides.
Two sides are congruent to the other two sides, and what else?
Side CD is bigger than
The other side isn't. So we're given information about all three sides. So this is going to be our side congruence. That's the theorem we would apply here because the information we're given is about all three sides. So now, what can we say, or your homework will say deduce. Deduce means figure out. What can we conclude about something in these triangles then?
That the triangles aren't congruent.
The triangles are not congruent. Let's be a little bit more specific. What one specific part can we compare that we're not already given?
I said the angles.
Okay, so we're not given any information about angles. So that would be a good thing to conclude. What two angles can we compare to each other and say that one of them is bigger than the other one? Angle A and angle D. Which one's going to be bigger? Angle A. Why?
Because it's 15.
Because the 15 is bigger than the 14. So across from A, there's a bigger side than across from D. So that means angle A will be bigger than angle D. Okay? Go ahead and work through the rest of these. Each color is a new problem. And in that red one on the top, a lot of students in first hour thought that was like a 50 with the 5 kind of sideways. It's a 40. So angle L is 40, angle P is 41, and that angle. Also in the middle for the green problem, this horrible chicken scratch says that angle 1 is right and angle 2 is obtuse. Okay, so go ahead and work through those remaining 7 questions that are there, and then we will talk about them.
Mrs. Chair, are the two triangles on the